In 1952, Boeing took a huge gamble by developing a prototype jet transport aircraft, risking more than the company's entire net worth on the project. Had the new aircraft failed, it could have led to the company's downfall. However, the 707 family ultimately became one of the greatest success stories in the history of air travel. On May 15, 1954, the Boeing 367-80, now famously known as the Dash 80, was unveiled to an enthusiastic crowd of employees and guests. Despite the setbacks the British had faced with the jet-powered de Havilland Comet, interest in Boeing's project remained strong. Everyone present understood the significance of the event, though few realized they were witnessing the debut of one of the most important aircraft ever built. The Dash 80 was designed as a one-of-a-kind prototype to demonstrate the viability of jet-powered transportation. Drawing on their experience with jet bombers, Boeing's engineers created an entirely new aircraft. Featuring a wing with a 35-degree sweep similar to military jets, but far more rigid. The wing flaps were divided to prevent interference from engine exhaust. 2 sets of ailerons were installed, one for high-speed cruising and the other for takeoff and landing. The Dash 80 featured a tricycle undercarriage, with 2 sets of main wheels that retracted into the fuselage and a double nose wheel. Powered by 4 Pratt & Whitney JT3 turbojets, which were the civilian counterparts of the engines used in the B-52. These engines were mounted in individual pods positioned below and ahead of the wings. This configuration not only improved weight distribution, but also made maintenance easier. The hinged side panels of the nacelles provided convenient access to the entire engine. Taxiing trials started almost immediately. But on May the 22nd, the Dash 80 encountered an issue when its port undercarriage collapsed. While the structural damage was minimal, the incident delayed the test program by 6 weeks for repairs. The Dash 80 measured 127 feet in length, with a wingspan of nearly 130 feet. Its cockpit was designed to hold a pilot, co-pilot and navigator, but the cabin did not feature standard passenger seating. As a purpose-built experimental aircraft, it had very few refinements. The fuselage interior was virtually bare and featured few cabin windows. Boeing had invested 2 years of secret development into the aircraft and had a clear vision of what they wanted to achieve. Tex Johnson, Boeing's senior test pilot, was selected to fly the Dash 80 on its much-anticipated maiden flight, which took place on July 15, 1954. As the crew worked through their checklists, they carried the company's future on their shoulders. In theory, both military and civilian markets held great potential for the aircraft. However, Boeing had been cautious and slow to enter the commercial market, partly due to resistance from both the traveling public and airlines toward jet airliners. Additionally, Boeing was heavily focused on the development and production of bombers. With the Dash 80, Boeing not only committed to the commercial market, but also gained a significant advantage over its competitors. Boeing's board made the decision to build the aircraft on April 22, 1952, convinced that the US Air Force would eventually need jet transports. They believed that a well-designed jet could serve both military and civilian markets. Powered by 4 turbojets, the Dash 80 lifted off after using just 2,100 feet of runway. Johnson, the test pilot, later remarked that the plane wanted to climb like a rocket, and he had to throttle back to stay within the airspeed limits for the maiden flight.
After flying the B-47 and the B-52, there was no doubt in my mind that the aircraft of the future, military and civilian transportation, was going to be jet. Of course, the prototype 707 was all built with company money, and it was a big responsibility. It was a gamble to some degree from a structure standpoint and a performance standpoint, but not nearly as much as the gamble of how long was it going to take the airlines to decide that's what they wanted and come up with the money to produce it.
Tex Johnston, chief of flight test for the Boeing Airplane Company, signed for the new jet transport and climbed aboard with Dick Flesh, his co-pilot.
With half of Seattle out there observing it, and all of the industry, airlines, engine manufacturers, competition looking down your throat, you had a lot on your mind. But once you fire up the engines and taxi out for takeoff, all that leaves you, and you're primarily absorbed in all the systems in the airplane, how it's reacting to the control. And as we taxied out, the people were jumping up and down, waving, and it was a celebration.
We're clear to come up on power.
We gave it the power and took off, and it rotated, and the first liftoff, the airspeed just kept building. I kept pulling the nose up, and we were light, relatively light, and we were climbing steep. And my co-pilot, Dick Flesh, said, "Man, is this thing going to climb straight up?" And after I landed, some of the engineers said, "We thought something was wrong with the control system. The airplane was climbing so steep. All I was doing is keeping on the best climb speed."
Flight test period, start. We've been climbing for 8,700 feet. All engine operation is normal. Hydraulic pressures are normal. The airplane feels good. The airplane taxied in, and when it had been parked, the pilot and co-pilot were congratulated by William M. Allen, president of the Boeing Airplane Company.
I could see the difference in that man from he shook hands with me before I climbed aboard on the initial flight. And to me, it looked like he was carrying a bit of he was stooped a bit at a load he was carrying, mentally, financially. When we landed at Boeing Field and he came out there, he was standing straight and tall and smiling, and it was beautiful to witness the difference in the man. IATA, the International Air Transport Association, which includes all the airlines of the world, had assembled in Seattle for their annual convention. And Boeing just happened to have a prototype airplane that was going to shrink the world by a factor of 2. But I've sold fighters and commercial airplanes, and you demonstrate them to impress people what they're capable of. And I knew that the prototype, and there's one maneuver that you can do with no hazard whatsoever. I decided that I would do a roll to impress the people. So I came across and did up with Shondell. One of my test engineers happened to have his camera with him, and he snapped a picture, which is famous today, with the airplane on its back, the engines up on top of the wing, and the Lake Washington below. I was called to Mr. Allen's office Monday morning, and Mr. Allen asked me what I thought I was doing, and I said I was selling airplanes. And explained it's a 1G maneuver, and it's absolutely non-hazardous, but it's very impressive. And his comment was, "You know that now, we know that, but just don't do it anymore." So it was fine.
The first test, which was smooth and uneventful, lasted only an hour and 24 minutes. In the next 8 days, the aircraft logged a total of 15 hours and 46 minutes of flight time. As the speed and altitude capabilities of jet fighters and bombers increased, They were forced to slow down and descend when refueling from piston engine transports. It didn't take long for the USAF to assess the Dash 80 and recognize its potential as a refueling tanker. Air-to-air refueling had become increasingly crucial, especially with the expansion of the jet fighter fleet during the Korean War, and the existing piston engine tankers were clearly insufficient. The need for an all-jet tanker was apparent, and the Dash 80 arrived at the perfect moment. Just 3 weeks after the Dash 80's first flight, and before it had even been tested as a tanker, Boeing received a contract from the USAF for 29 aircraft. This contract provided a significant morale boost for Boeing, especially since there had been little interest in the civilian variant at the time. The Dash 80 was soon equipped with a modifying flying boom, and a successful refueling test program quickly commenced. On October 5, 1954, the military version of the aircraft was officially designated the KC-135A when the contracts were finalized. Although the initial military order was relatively small, the potential was vast. In late 1953, the USAF had already begun seeking proposals to supply the Strategic Air Command with a jet tanker fleet to extend the operational range of its B-47 and B-52 bombers. 6 companies had been invited to make formal submissions. The USAF tender actually called for the provision of 800 tankers. The stakes for Boeing were immense. While the Dash 80 continued its test flights, production of the KC-135A began at Boeing's Renton factory. Though it was impossible to predict at the time, the KC-135A would remain in production for the next 10 years, with 732 units built in total. The KC-135A models were all equipped with upgraded Pratt & Whitney J57 turbojets and had an impressive fuel capacity, with up to 21 fuel tanks. The aircraft could also transport up to 160 troops or carry 83,000 pounds of cargo. Recognizing the strategic importance of polar regions, Boeing produced a specialized version of the KC-135A for Arctic operations. This version was designed to allow the crew to live aboard for weeks without needing ground support. Featuring a living area, bunks, and food storage facilities. The first production KC-135A Stratotanker was rolled out at Renton on July 18, 1956. The basic design of the KC-135A remained largely unchanged from the Dash 80 prototype, with the same overall dimensions. The first KC-135A tanker took flight on August 31, 1956. After undergoing initial testing, it entered service with the Strategic Air Command by mid-1957. The Stratotanker was notable for its lack of windows and its boom operator's station, with the high-speed refueling boom neatly mounted beneath the rear fuselage. As a military aircraft, the KC-135A was built to meet performance and safety standards that differed significantly from those required for civilian aircraft. Its J57 turbojets, equipped with water injection for additional thrust, produced intense noise and thick sooty smoke during takeoff. With a gross takeoff weight of 316,000 pounds, the KC-135A required a runway length of 13,600 feet, much too long for civilian airports. The KC-135A's airframe was constructed from a different alloy than the commercial variant. Its refueling system, the flying boom, was a Boeing innovation. The boom itself is 27 feet long and extends up to 46 feet, made of concentric tubes. The boom operator, positioned in the tanker, controls the docking process by maneuvering the boom into place. Once contact is made with the receiving aircraft, fuel is pumped from the KC-135's tanks through a series of valves and a pressure regulator, then into the boom and finally into the receiver. Standard speed booms could be swapped out for high-speed versions, designed to refuel faster aircraft like the SR-71 Blackbird. Boeing's contract with the Air Force gave the company the confidence and financial stability to further pursue the profitable civilian market. Pan American became Boeing's first 707 customer when it placed an order for 20 aircraft in October 1955. To Boeing's delight, Pan Am also ordered 20 Douglas DC-8s on the same day, even though that plane wouldn't fly for another 3 years. The inaugural 707 airline service was launched on the 26th of October 1958, when Pan Am flew 111 passengers from New York to Paris. Soon after, American Airlines launched the first scheduled passenger jet service from Los Angeles to New York. This cut the flight time across the US to about 4 hours, effectively halving it. In the first 18 days of operation, American Airlines transported 3,720 passengers, achieving an impressive load factor of 99.5%. The use of doors at both ends of the cabin allowed for quick boarding and disembarking, a significant advantage that necessitated changes in airport design and operations. The initial 707s were designated as the 707-120. Although the 120 model was primarily designed for domestic routes, Pan Am used it for transatlantic flights. The cabin could accommodate 121 first-class passengers or 179 in economy. With the introduction of longer-range 707 models, most of the 120 series aircraft were reassigned to domestic services. The 707's spacious fuselage and excellent performance quickly won favour with both passengers and crew. Its ability to fly above weather conditions, which propeller-driven liners had to navigate through, offered smoother, faster and safer flights. The cabin of the 707 could accommodate twice as many passengers as the older Constellations, making air travel a viable option for a growing number of travellers. Jet travel not only displaced competition from propeller-driven aircraft, but also heralded the decline of passenger ships, which even into the 1960s carried more travellers than holidaymakers. It's no exaggeration to say that a transportation revolution had begun. The competition soon intensified, with the emergence of the Douglas DC-8, the Convair 880, and various European models. Boeing was compelled to initiate a program to develop even more advanced jetliners. The initial risk of $15 million had been far surpassed, with new stakes approaching $100 million. Although Boeing maintained a significant production lead with the 707, Douglas gained traction with the DC-8 by promising greater payload capacities, longer range, more powerful engines, and other benefits for airlines and passengers. While Pan Am and American Airlines operated the 707-120, Boeing was already working on another important version of the aircraft. In response to the Douglas challenge, Boeing had announced the development of a new 707, offering greater range and capacity, the Intercontinental 707-320. In a hydrostatic test tank, the fuselage of the Intercontinental 707-320 was subjected to conditions equivalent to 40 years or 50,000 flight cycles. During testing, the fuselage was intentionally torn open and then subjected to cycles of extremely high pressures and heavy loads. Despite this, the damaged structure endured the stress without sustaining further structural damage. The 707-320 made its first flight on January 11, 1959. The success of the test series was so significant that just 35 days later, the aircraft was handed over to the Federal Aviation Agency, FAA, for certification trials. At Edwards Air Force Base in California, the Intercontinental underwent rigorous testing. It wasn't allowed to carry passengers until it received a certificate of airworthiness from the FAA. FAA test pilots conducted a thorough evaluation of the aircraft's flying characteristics, while ground engineers measured the performance of every component. The test team pushed the aircraft to its limits, flying it at altitudes ranging from low levels to the stratosphere, and at speeds from near stall up to 700 miles per hour. The Intercontinental 707-320 was over 12 feet longer than the 707-120, and featured a wingspan nearly 12 feet greater. It was the first model to be truly intercontinental, directly challenging the claims made by Douglas for the DC-8. Equipped with powerful Pratt & Whitney JT4 turbojets, the aircraft was capable of carrying a payload equivalent to 189 passengers. One of the final FAA tests involved installing ballast tanks in the cabin, filled with water to simulate the weight of 180 passengers and 45,000 pounds of payload. An additional 9 tons were added for extra measure, bringing the total weight of the aircraft to 316,000 pounds, a significant challenge for the FAA team of pilots, engineers and technicians. On the test day, conditions were ideal for a maximum weight takeoff, and the powerful turbojets required only 2/3 of the runway to lift the Intercontinental into the air. The 707-320 was also offered with the Rolls-Royce Conway Mark 508 turbojet as an engine option. BOAC was among the first to choose this engine, partly because it was a British product. The decision to purchase a 707 instead of a British aircraft had political implications. During the trials for its British certification, several extensive modifications were required, including a taller fin and a power-assisted rudder. These changes were later incorporated as standard features on the production line. The final test flight, conducted under full airline operating conditions, marked the first truly intercontinental flight of the jet age. The Intercontinental 707-320, sporting its new Boeing livery, was destined for Rome, Italy. William Allen, the chairman of Boeing, had good reason to smile. After departing from Boeing Field in Seattle, the 707-320 took a northeast route along the Great Circle Path. It flew over Canada, Greenland, Scotland, and Germany, cruising at Mach 0.78 and reaching a maximum altitude of 39,160 feet. The aircraft landed in Rome just 11 hours and 6 minutes after takeoff, marking the longest flight ever completed by a jet airliner up to that point. The following day, the plane continued its journey to Paris, Frankfurt, and Brussels before making a night stop at Heathrow. The FAA granted certification on September 23, 1958, and the transport revolution advanced further. By the end of 1958, Boeing's Renton plant was producing aircraft for airlines in 11 nations. In addition to the standard 707 models, they were preparing for both the Intercontinental versions and new high-speed developments. This variant would eventually be distinct enough to earn its own identity as the Boeing 720. Different versions of the aircraft were assembled simultaneously, with airline labels providing clues to their destinations. For instance, South African Airways and Varig of Brazil had orders for the Intercontinental 320, while a version for Lufthansa was equipped with Rolls-Royce Conway engines. This particular version gained popularity and was marketed as the 707-420. As production ramped up, 707 milestones were achieved rapidly. The 100th 707, adorned in the livery of Air India International, was also a 707-420. By the end of 1959, the medium-range 720s were being delivered to United Airlines. In total, 154 of this model were built in 2 different versions. Lufthansa flew back to Germany in record time. Sabena began operating 707 services to Africa and Russia. The 720 model achieved a speed of Mach 0.9, just as the designers had promised. A Rolls-Royce-powered Intercontinental 707 made history for BOAC by completing the first non-stop crossing of the North Pacific, flying from Seattle to Tokyo. Air France introduced the Model 320 on transatlantic routes, while Braniff launched a special tropical version of the aircraft. The new jets were so well received that, until sufficient numbers were in service, they were often filled exclusively with first-class travellers. Within a year of entering service, the 707 had carried over 2 million passengers. Australia's Qantas launched a new service from Sydney to San Francisco, one of many new routes established worldwide with the introduction of Boeing's aircraft. Despite significant pressure to purchase British aircraft, Qantas opted for the 707-120. Boeing had designed this short-bodied version specifically to allow Qantas to operate from Sydney's short runway, as well as the short runways of its Pacific stopover destinations. The longer routes, typically flown by Qantas, meant sacrificing some passenger capacity in favour of enhanced performance. This trade-off was more than compensated by the plane's improved range and speed. Although only 7 of these aircraft were built, they proved to be a great success. Qantas passengers experienced the Pacific Ocean journey reduced to just 15 hours. Production of the 707 series concluded in 1979. With a total of 917 aircraft across all versions built. These jets were operated by 62 different airlines, and in at least 300 of them are still in service today. One of the most definitive signs that the jet age had arrived occurred in December 1959, when a United States Air Force 707, the C-137A, landed in Rome. The jet, carrying President Eisenhower on a mission dubbed Operation Monsoon, was used for a whirlwind tour of 11 countries in 19 days, a journey that would have previously taken over a month. In Turkey, the president was welcomed by more than 400,000 people. In India, Eisenhower fulfilled one of his dreams by visiting the Taj Mahal with President Nehru. And upon arriving in Athens via Tehran, he had traversed the entire empire of Alexander the Great in just 1 day's travel. The president's journey continued through France, Spain, and Morocco before returning to the United States. The trip was a resounding success, with massive crowds welcoming him at each stop. However, its significance extended beyond diplomacy. For millions of people, it marked the beginning of a new era in global travel. Package tours have since become a common way for people to experience the world, echoing Eisenhower's journey. For Boeing, the mission highlighted the critical role of the 707. Although the military had its own version, the C-135, the USAF also acquired civilian 707s, which were designated as C-137s. The 707s replaced the Air Force's small VIP fleet and served as presidential transports for every president from Eisenhower to Reagan.
Thank you very much indeed for coming out on this cold night to welcome my party and me back home. It's certainly good to be here. Now, I must remind you that this morning we had breakfast in Madrid, our lunch in Casablanca, and now we are home at an hour which, by our getting up time, was 5 or 6 o'clock in the morning. So you can realize that this is not a time for a very erudite and informing speech.
These planes have become historical icons in their own right. For instance, one aircraft served as Air Force One from 1962 to 1972. Its most sober moment occurred when it was used to return the body of President John F. Kennedy to Washington after his assassination. The designation Air Force One has since been assigned to other aircraft, and it's the radio call sign used only when the president is on board. The VC-137s were operated by the Air Transport Wing. Each was configured with a custom-built interior, luxuriously equipped with only 22 seats. The C-137s were equipped with advanced navigation and communication systems to ensure global self-sufficiency. By 1989, presidential duties were transferred to a pair of Boeing 747s. In contrast to the limited number of C-137s, a substantial fleet of C-135s was produced. Many of these airframes have been extensively reconfigured and used in a wide variety of roles by different branches of the military. During the Vietnam War, the C-135 series was particularly prominent, with up to 10 different variants in operation simultaneously. Several C-135s were modified to carry electronic communications and intelligence equipment under the Strategic Air Command. The EC-135s, which served as airborne command posts, played a crucial role in the air war. These aircraft were originally designed for other purposes, but were adapted to the EC-135 standard.
The EC-135 aircraft looks like just about any other C-135 series aircraft in the Air Force inventory. The big difference is in the back. This is the SAC Airborne Command Post, known as the Looking Glass. The Airborne Command Post is a scaled-down version of SAC's primary underground command post and has the same basic capabilities. On a day-to-day basis, the underground command post controls SAC's forces around the world, but it would be a primary target for a potential enemy during wartime. If the underground command post is disabled, control of SAC's forces passes to the Airborne Command Post. Its battle staff is trained to manage any counterattack the President may direct and to direct the recovery of returning bomber and tanker forces. There's an Airborne Command Post flying over the Midwest 24 hours a day. Additionally, the Looking Glass aircraft has the capability to launch the Minuteman missile force if primary launch control centers are disabled.
The Looking Glass planes, a notable example of the EC-135s, were particularly significant.
Yeah, we're about ready to take off. Communications is the key element in maintaining command and control of the forces. Looking Glass is equipped with radios covering a wide spectrum of frequencies and includes the Air Force satellite communications system. At the touch of a button, the battle staff can talk to any SAC base around the globe.
An EC-135 designated Looking Glass was operated by a crew of 16.
Attention battle staff, Major General Buckman is on board the aircraft.
The EC-135s were equipped to remain airborne indefinitely, featuring both reverse fueling capabilities from SAC bombers via the boom and a standard refueling point. Each EC-135 was staffed by 5 flight crew members, 10 additional personnel, and a very senior officer. Over their service life, the EC-135s have been adapted into 8 different versions, reflecting their crucial roles and the special care given to their maintenance.
There's certainly been a lot of changes in the Looking Glass as far as the equipment and the performance of the aircraft over the past 21 years. But the basic mission to provide a survival command and control element has not changed. I think the great achievement is that it's been airborne continuously for 21 years, and that's due to a lot of dedicated people. We have outstanding air crews, battle staff, but mainly the people who supported on the ground have allowed this to happen. Primarily the maintenance people. They have to be out here 24 hours a day to ensure that we maintain this record and we can meet our commitments.
Although they were first produced in the mid-1960s, many EC-135s remain in service today. Notable milestones in their service include providing tactical command during the 1986 raid on Libya, confirming the Chernobyl accident through intercepts of Russian communications, and playing a key role in the Gulf War. In the late 1960s, the USAF awarded Boeing a contract to convert 2 Series 320 civil airliners for military use. Upon completion, there was no mistaking the EC-137s, as both were equipped with a distinctive 30-foot diameter rotating antenna mounted above the rear fuselage. These aircraft were the first 707-based AWACS planes, Airborne Warning and Control System. The AWACS were designed to function as a combination of a radar station, communication center, and command post. They were mobile, flexible, survivable, and resistant to jamming. With their capability for long-range surveillance in all weather conditions and over all terrain types, AWACS have become a crucial component of Western defense systems. As AWACS, the military 707s have truly demonstrated their capabilities as aerial sentries. A supersonic jet traveling at twice the speed of sound would move only 1/8 of an inch in the time it takes a laser beam to travel 1 mile. At the Air Force Weapons Laboratory in Kirkland, New Mexico, an airborne laser laboratory has been established. This aircraft was converted from an early KC-135 production tanker and is equipped with a distinctive narrow hump on top of the fuselage, which houses a rotating turret at the front. The turret, measuring 5 feet in height and weighing around 4,000 pounds, is a key component of the system. The turret is capable of rotating at about 100 degrees per second. The Airborne Laser Laboratory, operated by the 49th and 50th Test Wings, utilizes carbon dioxide laser technology to test its effectiveness on various materials used in aircraft construction. Engineers and scientists who developed the high-energy laser program are on board, allowing them to operate and refine the equipment they conceived, designed, and built. This airborne laboratory is another example of the diverse roles and configurations the 707 family has undergone over the years. Since the mid-1960s, the USAF has continuously maintained and updated its KC-135 tanker fleet. A significant upgrade for these tankers was the installation of fuel-efficient fan engines, which provided greater thrust and instant start capability. The re-engined KC-135s benefited from a 30% increase in thrust, coupled with a 27% reduction in fuel consumption, 85% less noise, and 90% fewer emissions. These advancements also extended the aircraft's lifespan. Alongside the new engines, the electronic, hydraulic, and flight control systems of these updated tankers were also modernized. Among the various unique variants of the 135 series are reconnaissance aircraft featuring a distinctive thimble-shaped nose. This bulbous nose houses sensitive radar equipment, and many of these planes are also equipped with camera ports and fuselage antennas. These aircraft play a crucial role in ongoing intelligence collection. Even more unusual were the 8 EC-135Ns, which had an even more pronounced nose deformation to accommodate a 7-foot diameter dish antenna. Converted in 1967, these planes were crucial to the Apollo projects. Operating in pairs, they ensured continuous voice communication between astronauts and ground control during manned space flights. In addition, they assisted in tracking the spacecraft. Despite the numerous innovative variants, the KC-135 tanker remains the cornerstone of the 135 series. Since the re-engineering program began in 1980, the operational benefits have been significant. The re-engined KC-135RE alone saves up to $400 million annually for the USAF due to reduced fuel consumption. Enhanced fuel efficiency allows these aircraft to offload more fuel, as they require less for their own needs. In addition to the re-engineering, 33 major modifications have been made to enhance strategic readiness. These upgrades have reduced maintenance needs, enabling crews to deploy more quickly. Around the clock, every day of the year, KC-135 crews are on alert globally. During the 1986 raid on Tripoli, the tankers were crucial. They refueled the F-111s at least 4 times on their way to Libya and twice on the return journey. This capability was vital, as both Spain and France had denied the United States overflight rights. In addition to the tankers, an EC-135E provided tactical command for the raid, and another C-135 was tasked with delivering photographic evidence back to Washington. During Operation Desert Storm, both US and French KC-135s played a crucial role, providing in-flight refueling for all US aircraft as well as several Allied aircraft. The updated KC-135s, equipped with powerful new turbofan engines, benefited from a substantial increase in thrust. This improvement allows these aircraft to take off with a full load from a distance up to 2,500 feet shorter compared to earlier models. The maximum takeoff weight has been increased to 322,500 pounds. The efficiency of the new fan engines translates into significant operational benefits. The aircraft can offload 65% more fuel at a 1,500-mile radius, and an impressive 150% more at a 2,500-mile radius. Currently, the average C-135 airframe has utilized only a third of its expected 30,000-hour lifespan. There seems no doubt that the jet will still be in service beyond the current plans for their retirement around the year 2020. In 1972, the Dash 80 was retired and donated to the National Air and Space Museum. It remained in storage in the Arizona desert for 18 years due to a lack of exhibition space. The Dash 80 had been a pioneer in modern jet transport and a testbed for new aircraft and engines. In 1990, the aircraft was brought out of storage for a final restoration. A dedicated crew undertook the meticulous task of returning the Dash 80 to flying condition, checking and rechecking every rivet and overhauling the old Pratt & Whitney turbojet engines. After the extensive refurbishment, the Dash 80 was prepared for its final flight back to Seattle, the city where its groundbreaking journey began. The Dash 80's final flight to Seattle was a significant event. Piloted by Paul Bennett and co-pilot Jerry White, the aircraft made a stop at Moses Lake, Washington, to pick up a group of distinguished guests and longtime admirers. The restoration of the Dash 80 had been a major effort, involving 15 technicians and engineers working a total of 1,000 man-hours. Among the notable passengers was Tex Johnson, the senior test pilot who'd first flown the Dash 80 over 35 years earlier. The Dash 80's preservation is indeed a fitting tribute to its historical significance. By using dry ice for paint stripping, Boeing not only ensured that the aircraft's restoration was environmentally friendly, but also highlighted the ongoing innovation in aviation technology and practices. Restoring the Dash 80 to its original livery and showcasing it in the Boeing Museum of Flight honors its pivotal role in the evolution of commercial aviation. It serves as a living testament to the advancements and milestones achieved in the industry thanks to the Dash 80's pioneering efforts. The Dash 80's legacy is a powerful reminder of the impact that a single aircraft can have on an entire industry. Its journey from a groundbreaking prototype to a symbol of aviation's golden age illustrates how innovation can set the stage for a monumental change. Boeing's transformation from a minor player to a dominant force in civil aviation is a direct result of the Dash 80's pioneering role. The aircraft's recognition as one of the Smithsonian's most important aircraft highlights its enduring significance in the history of flight. The Boeing 707 indeed transformed the aviation industry, turning air travel into a feasible option for millions of people and shrinking the world in unprecedented ways. Its role in both civil and military aviation is a testament to its design's versatility and impact. Its robust design ensures that it will remain a fixture in the skies, a lasting symbol of the jet age and the innovative spirit of the 1950s.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.